All right, welcome to The Explainer. Today, we're going to pull back the curtain on programming. We're talking about the absolute core building blocks of C Sharp. Yeah, that's one of the biggest, most powerful programming languages on the planet. So let's just dive right in.
I mean, it really does seem like magic, doesn't it? You've got these silent pieces of metal and plastic, and suddenly they're running these incredible games, apps, websites. How? Well, it's not magic, it's logic. It's actually a conversation. And like any good conversation, it all has to start with a single sentence.
And this line right here, this is basically the programming version of hello. In this case, we've got merhaba dunya, which is Turkish for hello world. It's just a simple, direct command. All it does is tell the computer, hey, put these words on the screen. And believe it or not, this is where pretty much every programmer's journey kicks off.
So, if we're going to have that conversation, we need to learn the rules, right? We have to understand the basic structure, the grammar of the language. This is how we organize our thoughts in a way the computer can actually follow.
Because let's be real, without organization, code becomes a total disaster fast. So C# gives us a couple of main tools to keep things tidy. First, you've got a namespace. Think of that as a huge filing cabinet for a big project. It stops you from accidentally naming two different things the same thing. And then, inside that cabinet, you have a class, which is like a single folder for grouping all your related instructions together. Nice and neat. Okay, so every single C# program has to have a starting line, and that's the main method. You can think of it like the front door to a house. The moment you hit run, the computer is looking for that one specific spot to get started. From there, it just follows the instructions, one by one. It really is the command center for your whole program.
All right, so our program can speak a little, but it's got no memory. It can't remember a thing. And to do anything useful, you've got to have a memory. So we're going to give it one. And we do that by creating something called variables.
And this analogy really gets to the heart of it. It's like you wouldn't try to store water in a cardboard box, right? Same idea here. You can't just stuff a word into a variable that's only built for numbers. Picking the right box and programming is absolutely crucial. And if you get it wrong, well, you can run into some really weird, surprising problems.
Okay, just look at this. This is wild. On the left, we're asking the computer a simple math question. What's 0.7 minus 0.3? We're using a type of variable called a float. The answer should be 0.4, obviously, but the computer says our check is wrong. But then, look at the right. We do the exact same math, but with a different type, a decimal, and suddenly, it's correct. So, what on earth is going on here?
And here is the answer. This table solves the whole mystery. You see, types like float and double are built for speed, not for perfect pinpoint precision. They're great for things like video game graphics, where a tiny little error doesn't matter. But the decimal type? That one is designed from the ground up for rock-solid accuracy. So the takeaway is super simple but incredibly important. If you're ever dealing with money in your code, you always use a decimal. No exceptions. Okay, so right now our program is pretty dumb. It just runs in a straight line from top to bottom. But that's not how smart programs work, right? The real power comes when we teach our code how to make decisions, how to react based on the information it's given. And this right here, the if-else statement, is the most basic decision-making tool in all of programming. It is literally a fork in the road for your code. You just ask a simple true or false question, like, is this number less than 0? If the answer is yes, the code goes down one path. If it's no, it goes down the other. Simple as that. But what if you have more than two choices? What if you have like 5 or 6 paths? Well, you can just chain these things together. You can ask, is the number 0? Okay, if not, is it 1? If not that, is it 2? And it works, technically. But you can see how this would get really messy and hard to read pretty fast. And that's where this comes in. This is a much more elegant solution. On the right, we've got something called a switch statement. Now, it's doing the exact same job as that messy code on the left, but just look at how much cleaner and more organized it is. It basically just says, hey, take this value and switch to the one case that matches it.
It's just so much easier to read.
Okay, let's recap. We've taught our program how to speak, how to remember things, and how to make decisions. Now, it's time for the real magic. We're going to teach it how to do work for us. The same work over and over and over again, without complaining. And this is where loops come in. This one line of code is an absolute powerhouse of automation. This is a for loop, and it's a complete, self-contained recipe for repetition. It's basically like telling the computer, all right, I want you to do this next task exactly 10 times. But how does it actually know how to do that? Well, let's break it down. That single line has 3 simple parts. The first part is the initializer. It just runs once, right at the start, to set up a counter, usually at 0. The second part is the condition. That's the gatekeeper. It checks, hey, should we run again? And if the answer is yes, the code inside the loop runs. Then, part 3, the update happens. It just adds 1 to the counter, and then the whole thing repeats, right back to the condition check. And this is the payoff, right here. You can see it visually. We write one simple line of code, and the computer performs 10 separate operations for us. Now just imagine if you needed to do something 1,000 times or 1,000,000 times. That is the incredible power of a loop. It's all about getting maximum output from minimum input. All right, so we've got all these amazing tools now. But, as our programs start getting bigger and more complex, we really need a way to keep everything organized and to stop ourselves from writing the same code over and over. And that is the final piece of the puzzle for today. A method is basically like creating your very own custom command. So let's say you write a little block of code that perfectly calculates the area of a square. Well, instead of copying and pasting that code every single time you need it, you can package it all up into a single method, maybe call it calculate square area. Then anytime you need it, you just call that one command. No more copy pasting. And C# has this really clever feature called method overloading. Get this. It lets you create multiple methods that all have the exact same name as long as they accept different kinds of inputs or parameters. So here, for example, we've got 3 totally different methods, but they're all named foo. One takes nothing, one takes a single number, and the third takes 2 numbers. So you might be asking, how does it know which one to use? Well, the compiler is smart. It just looks at how you've called the method in your code. If you call foo and you give it 2 numbers, it says, aha, I know which one that is, and it uses the version built for 2 numbers. It's kind of like having a key that can fit into multiple locks, just by changing its shape a little bit to match. And just like that, we've covered a ton of ground. I mean, think about it. We started with just a simple hello, and now we've seen the tools that let programs remember information, make smart decisions, repeat tasks endlessly, and even organize themselves in a really clean, elegant way. So let's just recap the big ideas. These are the 5 pillars we've talked about. First, you need structure, right? Your namespaces and classes. Then you need memory, your variables. After that, you need decisions. That's your if and switch statements. Then you need repetition, your loops for automation. And finally, reusability, with methods to write smart, efficient code. And here's the thing. Every single piece of software you use, I don't care if it's the OS on your phone or the most complex video game you can imagine, it is all built from these exact same fundamental blocks. This stuff is the alphabet, it's the grammar, it's the sentences of the entire digital world. So now that you know the basics, the only real question left is, what are you going to build?